Okay guys, we're gonna do a quick review. This is gonna hopefully be a short video on how to form compounds. So here we go. The first one is magnesium bonded with phosphorus. The first thing we gotta see is the two elements, right? We have magnesium and we have phosphorus. So in order for you to successfully make a compound, knowing that this is a metal and this is a non-metal, that it's going to form an ionic compound. And if it forms an ionic compound, it's going to form based on their charge. So knowing that, we need to determine what is the charge of each one. So we go to magnesium. Okay, the chemical symbol is Mg. If you look on your periodic table of ions, or you just know that it's in group 2, you know that magnesium forms an ion Mg2+. Yes? Let's go to phosphorus. Phosphorus is a non-metal ion, or a non-metal element. So let's go ahead and go to phosphorus. And if you look at the periodic table, or look at your periodic table of ions, you know that phosphorus forms the ion phosphide, which is phosphorus 3-. Again, this is review. So now that we know what types of ions they make and what the oxidation state of each ion is, remember, this is the oxidation state. The oxidation state is just a fancy way of saying the charge. Then we can determine how many of each element we need to successfully form a compound. Now, there's two ways to do it. The first way is to take a look at the charges. Magnesium is a 2+, and phosphorus is a 3-, right? And if we wanted to get these guys to cancel each other out, well, we can just multiply this guy by 3 and this guy by 2, right? What happens here is you get 2 times 3, that gives you 6. Okay, and then if you look at the other side where you get -3 times 2, that gives you a -6, right? So if you have a 6 minus 6, that equals 0. So then that gives you a compound now that is Mg3P2. Yes? Now, the other way you can do it is if you have magnesium. Sorry, let me erase that. If you have magnesium at a 2+, and you have phosphorus at a 3-, then you just got to do the fish. This guy becomes a subscript here, this guy becomes a subscript here, and you get exactly the same answer. Mg3P2. Notice that the charges of each ion become the subscript of the other. Okay, so let's try another example. Here we have calcium nitrate. Okay, now what we're doing here is we're translating from chemical name to chemical formula. Okay, there's a few things that we got to do first. But the very most important thing to realize here is that if you see an ion that ends with an ATE or an ITE, okay, that's got to be the red flag that tells you I need to look at polyatomic ions. Elements from the periodic table, you will always end with an IDE, not an ATE. So if you got like a T anywhere in there, you need to start looking at your polyatomic ions. Okay, now what's the first step? The first step is to find the chemical symbol / formula of the ions. Okay, so based on this, we already know that calcium, if you don't know, you have a periodic table, has a chemical symbol of Ca. Okay, nitrate is a polyatomic ion, and that has the chemical symbol or formula because it is a compound of NO3. Okay, all right, so calcium is Ca, nitrate is NO3. All right, second step. Okay, once we got the symbols, all we got to do now is find their charge. Okay, if you look at the periodic table, we know that calcium is a group 2 element, so calcium is going to have a 2+ charge. And according to our polyatomic ion sheet, nitrate carries with it a 1 minus charge. So there's our charge there. Okay. Now, once we have the chemical symbol and we have their oxidation states, all we got to do now is make the bond. So this 2 becomes a subscript here, and this 1 becomes a subscript here, doing the fish, and then we get our compound. Okay, calcium, we don't need to write the 1, parentheses, NO3, and then, whoops, let me erase that. There we go. And then outside of that goes the 2. Okay, so there's our compound, calcium nitrate. Now, I want you to pay attention to something. This 3 right here does not change. Okay, nitrate is a polyatomic ion. You have to keep that 3 no matter what. And then the 2 that we get from calcium, this one, goes on the outside of the parentheses. Okay, so you have to treat polyatomic ions like nitrate as if they were single elements. You don't split them up, you don't move the 3, and remember that the number or the subscript come from the charges. They come from the charges. Okay, so now we've made a new compound, calcium nitrate. Just remember that every time you make a new compound, whether it's in a chemical reaction, whether it's reactants, whether it's products, you always have to do this process. Okay, find the charges, cross them over, get the subscripts. All right, if you guys have any questions, let me know.